Welcome to section 2.5, Variables. In this video, we will talk about what is a variable, the different types of variables, how to declare a variable, naming rules, and finally we will talk about printf and the different format specifiers for the different types of variables. So what is a variable? Well, when you write a program, most likely you will need to store, access, and manipulate data. A variable is what stores and identifies the different pieces of data that we use in our program. A variable will consist of three things: a type, a name, and the value that it holds. To declare a variable, you need to do two things. You need to specify a type, and you need to give the variable a meaningful name. When we declare a variable, the compiler associates the identifier or the name of the variable with that variable type. The second thing that the compiler does is that it reserves enough space in memory for that specific type of variable. As an example, if we want to declare a variable that will hold the number of students in a classroom, we would create that variable as follows. We would give it a type, int, and a meaningful name, number of students. Again, int is the type of variable, integer, and it holds whole numbers. Since you can't have 2.5 students or 20.5 students, it has to be a whole number, so we choose int. The second thing is number of students. It's a meaningful name. This way we can recognize what this variable is holding. And finally, you have to remember that you always end your statements with a semicolon. Now let's take an example. Let's declare an integer variable and call it num of apples. Then let's assign the number 80 to num of apples. And finally, let's print the value stored in num of apples on the screen. Now please open the file example-2-5-1.c in code blocks. So once you open the file, this is the code you will see. Now remember, to declare a variable, you need to specify a type and give that variable a name. We do that right here on line 5. The type is int for integer, and the name is num of apples. We use int because the number of apples has to be a whole number. Second, to initialize that variable, to give it a value, we do that on line 7. So num of apples equals 80. Now remember to use the semicolon at the end of every statement. The third thing we have to do for this example is that we have to print the value being stored in num of apples on the screen. We do that using the printf statement on line 11 right here. Now remember, the %d over here will be replaced by the value being stored in num of apples right here. Let's compile and run the code. So to compile, remember, we have to use the gear sign here. Build, click on build, and we're gonna look at the build log here. We have 0 errors and 0 warnings, so everything is good. Now let's go and run the code, and here we have it. The variable num of apples holds the value 80. And that's the value we assigned it right here on line 7. Now let's talk about the different types of variables. So since we have different types of data, it only makes sense that we should have different types of variables suitable to hold the different types of data. So for example, we have int, float, double, char. So an int stores whole numbers. For example, int age equals 21. On the other hand, float will store a number that has a fractional part to it. For example, float account balance equals 12.50. Next, let's look at the variable type char. Char stores single characters. To declare it, we say char, C-H-A-R, then we select a variable name, in this case menu underscore selection, equals B. The single character that is assigned to a variable of type char has to be encased between single quotation marks. Now let's look at identifier naming rules. An identifier is simply the name given to a variable. So the first rule is a variable name is case sensitive. For example, client with capital C, a variable name, is not the same as the variable name client with a small c. They are two different variables. Next, no spaces. So you can't have spaces in variable names. If you want to create a variable name called client name, it is incorrect to do this, client space name. The correct way would be client underscore name or client name, one word. Next, you can't have a special character, a C special character in the name. Any of these characters are considered a special character, and you can't have them in the variable name. The next rule is you can't have a C keyword. In the next slide, I provide you a list of the C language keywords. Next, you cannot start the name, the variable name, with a number. So 1 John is incorrect. You can, however, start your variable name with an underscore, but it's not recommended. And so finally, a variable name can contain underscore, a number, or letters, such as John underscore Smith underscore 007. This is the next slide, and it contains the C language keywords. Any of these words cannot be used as a variable name. Finally, I want to talk about printf and format specifiers. Format specifiers used with printf gets substituted with variable values. Different variable types will need different format specifiers. For example, for an integer, we use %d. For a float, we use %f. For a hexadecimal integer, we use %x. For a single character, we use %c. For a string, we use %s. And for a pointer, which points to a memory address, we use %p. And finally, if you want to display the % itself, you're going to have to do % in between the quotation marks. Now let's take an example. Please open file example-2-5-2.c in code blocks. Once you have opened the file, you will see the following code. In this code, I will declare and initialize different types of variables. First, we declare an integer, int num students equal 10. Next, we declare a float. So float account balance equals 20.1. Next, we declare a hexadecimal integer, and we do that the same way as a regular integer. The only thing is, when we assign it a number, we type it in hexadecimal. So the number 10 is 0x0a in hexadecimal. And the next variable is char, which holds single characters. So here we say char last initial equals a. When you want to assign a char variable a single character, you have to put that single character between single quotation marks, such as here. Next, we have a string. We will talk about strings in section 2.8. For now, just know that the string header will be stored in the variable name. And finally, we will declare a pointer variable. A pointer variable is a variable that holds the address of another variable. So in this case, we say int star pt, the name of the pointer, equals ampersand num underscore students. The ampersand operator provides the address of the variable num students. And now we will use printf statements to display the values stored in these variables. So on line 12, we will use the printf statement right here to print two values. The first value is the value stored in num students, the variable num students, which is 10. And the second value is the address of the variable num students. Like I said, we use the ampersand to get the address of the variable num students. %d will be replaced by num students, or the value that is stored in num students, and %p will be replaced by the address of the variable num students. Next, on line 13, we will use the printf statement to print the variable or the value stored in the variable account balance. And so %f will be replaced by the value stored in the float variable account balance. On line 14, we will use the printf statement to print two values. The first is the variable hex, which is a hexadecimal integer, and the next is num students. But this time we will print num students in hexadecimal format. Next, on line 15, we use the printf statement to print the value stored in last initial, which is a char variable. And so $C will be replaced with the variable, with the value stored in the variable last initial. In this case, A, capital A. Then we have $S, which will be replaced by the string name. Name holds the value hider, and so $S has to be replaced by hider. Next, on line 17, we will print two values again. The first value is the address that is being stored in the pointer pt. This address, if you remember, belongs to the variable num students. The second value we want to print is the value stored in that address. And so if everything goes well, this address, which will be printed here, has to be the same address that is printed right here, because it's the same address, because it's the address that belongs to num students. The second value has to be the value stored in that address, and since that address belongs to num students, it has to be 10. Finally, we will print the symbol $, twice, here and here. So now let's compile and run this code. So we will use the build button right here. We build, we look at the log, the build log, and we have 0 errors, 0 warnings, so everything is good. Now let's run the code. And this is what we have. The value 10 is stored in the address 0061FEFC. This address belongs to the variable num students, and the value 10 is stored in that address or in that variable. Next, I'm going to move the screen here. Next, we have account balance is $%F. So account balance is $20.1, and this is what we assigned the floating point variable account balance. And next we have variable hex equals A. A is 10 in hexadecimal. We have assigned it right here to the variable X. And then it says, and num students in hex equals A. Again, this is because 10 in hexadecimal equals A. The next line says my last initial is A, and we did that right here on line 8. Char last initial equals A. The next line says my first name is Haider. We declared and initialized that string right here on line 9. And on line 16, we printed that string. My first name is %S. This was replaced by name, which holds the string Haider. And so my first name is Haider. The next line says pointer PT is pointing to the address 0061FEFC. Now remember, on line 10, we said we declared a pointer PT and we assigned it the address of num students. Now, what's the address of num students? It's right here. 0061FEFC. 0061FEFC. It's the same address. That's because we assigned the address of num students to the pointer PT. It is stored in PT. And then it says, which has the value of 10. Well, the address of num students is holding the value 10. And finally, we have this line. You have to use double %sign to display the symbol %sign. And we did that right here. You have to use double %sign to display the symbol %sign. And when it's printed, it only shows one %sign each time. Now let's go back to our slides. And so with that, section 2.5 is done. And next we have section 2.6, which will cover stack versus heap memory.